Good evening, everyone. Am I audible? Very good evening, all. Am I audible? I warmly welcome you all for this 30 days masterclass on battery management system. Good evening. Good evening, Sahana. Good evening, Roshan. Good evening. Good evening, Karthik. Good evening. Very good evening, everyone. I hope you guys are super excited for this 30 days masterclass series on battery management system. If you are excited, you just post your comment, I am excited in your live chat. Good evening, Naga. Good evening. Good evening, everyone. Good evening. Good evening. Once again, I warmly welcome you all for this 30 days masterclass on battery management system. And this is Radhika. I'm your mentor on this 30 days journey on battery management system. Good evening, Shanmugapriya. Good evening. Shall I start now? Yeah, okay. So first, at pantechelearning, we have spent 20 years mastering our field. Now we are sharing that expertise through edutech platforms to help you succeed in your learning journey. Recently, we celebrated our 20th anniversary, 2 decades of excellence in tech education. Now we are excited to share our experience and knowledge with you. So let's see, this is our vision, is to help 10 million students easily learn the technology. In this live session, we are here to turn our vision into reality. Over the next 30 days, we will cover a wide range of topics on battery management system. Let's see the day-wise agenda. So first, we will see building battery model simulations and battery pack simulations. So we will start by creating a basic battery model simulation and then move on to battery pack simulation using a MATLAB and Simulink and Simscape. Next, day 3 to 5, we are going to designing battery models that consider some thermal influences. Then we progress to developing our battery pack models that incorporate a cell aging and critical aspect of the battery performance. Next, we focus on constructing our battery pack models with integrated cell balancing circuitry. What is cell balancing and what all the methods will be available in cell balancing? So cell balancing is an essential feature for ensuring a battery monitoring system. During these days, 9 to 11, we will see battery charging and discharging methods and covering the simple circuit design and what is the principle behind the passive cell balancing and active cell balancing. Next, we will explore various methods for estimating the state of charge, and some state estimation methods will be there using a Kalman filter Coulomb counting method. And these are all the methods to estimate the state of charge of a battery. So we also touched upon the battery state of health estimation algorithms. So we will see. So day 15 to 17 these days are dedicated to developing algorithms that control battery temperature using some heaters and coolants and designing the thermal analyzers for both new and aged battery packs. We also create some battery controller by using MATLAB and Simscape. Then we enter into the equivalent circuit models. This battery equivalent circuit models starting with the 1C or 1 RC branch equivalent circuit or a 2 RC branch equivalent circuit for the lithium batteries, and then simplifying the algorithms to design this equivalent circuit. So we explore different methods of equivalent circuit to design the battery. Next, day 21 to 23, we introduce some testing BMS software, communication protocols like CAN bus, LIN bus, that discuss data exchange between the BMS and other vehicle components. Day 24 to 26, we will see including some testing a battery management system in MATLAB Simulink and generating code for the BMS algorithm. So in the final week, we designed a closed loop testing environment for the battery management system by using MATLAB Simulink or Simscape that manage some requirements, deploy BMS algorithms on hardware and test them with a free master application. So this is our 30 days masterclass agenda. By end of this 30 days, you will have a solid understanding of battery management system and related topics. Over the next 30 days, we will explore a wide range of projects that each aligned with the topics we are covering. So from creating a basic battery model simulations to developing advanced battery management systems and hands-on projects will deepen your understanding and equip you with practical skills in battery technology and systems. Get ready to join this exciting 30 days journey. So first we will see job opportunities in the EV industry and BMS. According to the Ministry of Skill Development and Entrepreneurship, many employment opportunities will be created in India's electric vehicle industry over the next decade. By 2050, Niti Aayog estimates that the EV sector will produce more than 2 million extra jobs. At present, the average yearly income for an electrical design engineer in India, 4 lakhs with the salary range from 2.0 to 9.3 lakhs. So the government experts the EV industry to help the country's economic development also. So the electric vehicle industry is gaining a popularity due to its positive environmental impact and also the low operating expenses. So these companies like Tata, Benz, and Maruti Suzuki, Tesla, Siemens, and Ola Electric are all part of the electric vehicle industry. If you are interested in electric vehicle, you can find jobs related to electric cars and that technology in these companies. So what are the roles behind this electric vehicle industry and BMS? So there are a lot of roles, including designing electric vehicle and making the EV components, BMS application engineer, like that. So companies like Tata and Tesla will create a job opportunity in various loads. And many companies, Tata Motors and Ola Electric, have planned to put a charging station at different sites throughout the India. So grab this opportunity of your electrical engineers will get the possibility to work in these charging stations also. In recent news, the Tata Group has taken a significant step forward in the electric vehicle industry by announcing their plans to establish the Gigafactory for lithium-ion cell batteries in Gujarat. So this initiative aligns with the growing demand for electric vehicles and sustainable energy solutions. Additionally, Tamil Nadu government has shown strong commitment to EV sector to create a 1.5 lakh jobs in the industry over the next 5 years. So these developments highlight the expanding opportunities and importance of the EV sectors in the present and future job market. Next, we will see the career path. We will start as an engineer in a product development and validation, then specialize in design or become an application engineer, then move on to vehicle performance and integration manager. As you gain experience from these roles, you can transition into the leadership positions like a chief engineer or a vice president, like that. So start with the career is begin your journey as an engineer in product development and validation, then go to the design engineer. After that, shifting to the application engineer role that closely collaborating with the customers. Provide some technical support and troubleshoot issues and optimize the utilization of electric vehicle and BMS products, like that. Next, you will specialize in vehicle performance or integration. So this is a well-structured career path in the electric vehicle and BMS field. Takes you from entry-level engineer to the specialization and leadership roles. So first, as we enter into the topic of BMS, first I want to take a moment to acknowledge the importance of this subject. So basically, battery management systems in the sense, these are the crucial components in various industries, from electric vehicles to renewable energy system. So let's get started and exploring this exciting topic together. As we are living in a modern lifestyle of a 21st century, the consumption of energy has increased in our daily life. Today, every person has a personal electronic device such as phones, laptops, a tablet, a smartwatch, like that. So these all devices are recovered one secondary power supply that is called battery. So the power of a battery should be managed and properly and safely. Let's see what is BMS. Do you have any idea about this BMS? Do you have any idea about what is BMS? That's no issue. Okay, I will tell you. So basically, BMS, it stands for a battery management system. So that monitors the individual cells in a battery pack. It then calculates how much current can safely go into the battery, that means charge, and come out, that means discharge, without damaging the battery. So this is called battery management system. Yeah, like that only. Control the power. Yes, monitoring and controlling. So in simple words, we can say that battery is the heart of your electric vehicle and BMS is the brain of your battery. Similar to how your brain maintains and monitors your bodily functions to keep you alive. The same way, BMS protects your battery from damage and prolong its life and keep the battery operational within the safe limits. This is what a BMS is. Next, we will see the simplified diagram. So first, this is our BMS board. So this BMS is a like the guardian of your electric vehicle's battery. It's constantly collects the important data such as the voltage, current and temperature from the battery pack, and then it processes this information and provides the valuable outputs to the vehicle system and the driver. So this SOC is a state of charge and state of health, and also it indicates some fault or status of the battery. So in simple terms, the BMS keeps a close watch on the battery's well-being and lets you know how much charge is left and how healthy the battery is and if there are any problems that need some attention. So ensuring your electric vehicles run smoothly and safely. Yeah, correct, Shrikar, correct. Let's see the battery parameters. So these are all the important parameters that available in the battery. So first one, it is the SOC. SOC in the sense state of charge. SOH, it represents the state of health. SOP is the state of power and DOD is the depth of discharge. SOC, it shows the remaining capacity of the battery while in use. We can say it's a fuel gauge of the battery. We can see SOC of a battery of electric vehicle devices in terms of the percentage. Next one is a SOH. So it's a very important parameter to estimate the state of health of the battery. SOP in the sense it is a battery's present ability to provide power under some certain voltage or current limits. Basically, SOP depends on SOC and SOH and temperature and time. For example, when SOC of a battery A is a 10% in the sense, SOC of a battery B is 80%. Then what will be the SOP of the battery? Answer is SOP of a battery A will be far less than the battery B. So SOP is nothing but a state of power. It is the battery's present ability to provide power under certain voltage or current limits. It mostly depends on SOC and SOH, that means state of charge and state of health. For example, when SOC of a battery A is 10% and SOC of battery B is 80%, then what will be the SOP of that battery? The answer is SOP of a battery A will be far less than the battery B because the direct relation of a power and energy. So SOP of a battery is very much important and it has to be accurately predicted or calculated in real time, assuming some constant current rate. Next one is the DOD. DOD in the sense a depth of a discharge. So what is that? It basically indicates a percentage capacity of the battery which has been discharged relative to the overall ideal capacity of the battery. SOH in the sense that is a state of health. This DOD, that means the depth of discharge, it always recommended that the battery should never be fully charged or discharged. So we know a frequent charging and discharging may shorten the battery's life. For example, battery pack capacity is 10 kilowatt hour and the cell manufacturer suggests to keep the depth of discharge is 90%. That means only 9 kilowatt hour energy has to be used keep the battery for charging again. So the battery should never be charged 100% and should never be discharged 0%. So this is a significant way the depth of discharge can increase the battery's life. So Arvind, SOC in the sense state of charge. It indicates only how much charge is left in your electric vehicle battery. In future classes, we will see calculations on SOC and SOH like that. SOH that reflects the overall health and longevity of your electric vehicle battery. Yeah, the same like a mobile. Depth of discharge, it measures how deeply you have used your electric vehicle battery capacity before a recharge. So that is what a depth of discharge. DOD in the sense, depth of discharge. It measures how deeply you have used up your electric vehicle battery. Next, here why BMS is recording electric vehicle. To prevent battery failure and critical situations, there is a need for some supervising system that ensures the battery functions properly in the final application. So this supervising systems is referred to an battery management system. So there are a lot of primary functions in electric vehicle. So it measures the individual cell voltages and then BMS must measures the temperature at different points as possible to the battery. And also it measures currents flowing through it. And at last the BMS should communicate information to the control units and undertake some actions to ensure the battery will be operated within the safe limit. So the BMS should balance the battery cells passively or actively. And also this BMS should provide the thermal management. To improve the quality of battery and safe operation, so BMS plays a important role in the application of electric vehicle. Next, we will see some important types of batteries. So there are four type of batteries that are commonly used for electric vehicles. First one is the lithium ion batteries, and another one is the lead acid batteries and nickel metal hydride batteries. At last we have ultra capacitors. Lithium ion batteries. So these batteries offer a high energy to weight ratio. And then allowing to store a lot of energy in a relatively small and lightweight package. So this is a very crucial part for electric vehicles. It provides a longer driving range without adding some excessive weight. And also it has a long life cycle. Lithium-ion batteries can endure a large number of charge and discharge cycles, making them suitable for a long lifespan expected from the electric vehicles. They can be charged relatively quickly, which is convenient for electric vehicles who want to recharge their vehicles in a reasonable amount of time. Then, lithium-ion batteries have a compact design and allowing for a flexible placement within the EV. So next we will see the nickel metal hydride. This nickel batteries are known for their durability and ability to withstand the extreme conditions, making them suitable for certain applications within the EV. So next we will see the lead acid batteries. It has a low cost because this is inexpensive compared to the other batteries. And also it requires a simple maintenance. So these lead acid batteries are widely available, making them accessible for the smaller electric vehicle markets. So next one is the ultra capacitors. That means the super capacitors. So rapid charging and discharging. So ultra capacitors can store and release energy quickly, which is useful for applications where a rapid burst of power are needed, such as a regenerative braking in an electric vehicle. So they also have a longer life cycle compared than the many battery types, and also it has a high efficiency. So each of these battery has its own some a set of advantages and disadvantages, making them suitable for different types of electric vehicles and also applications in the EV industry. So manufacturers choose the best option based on factors like cost, performance, and specific use cases. So mostly we are using um, lithium ion batteries for electric vehicle. Let's see what is battery pack. Yeah, ultra capacitor is a such powerful battery. Do you have any idea about what is battery pack? Post your answer in the live chat. Do you have any idea about battery pack? What is battery pack? Yeah, like that set of batteries, combination of cells. Very good. So basically, battery pack is a very crucial component in electric vehicles. It stores the electrical energy in the form of chemical energy. So the pack of consists of numerous individual battery cells connected together to provide the necessary voltage and capacity. When the electric vehicle is in use, the battery pack supplies the electricity to power the vehicle's electric motor. And this is what is battery pack. We will discuss in later series connections and parallel connections like that. So here there are three commonly cell structure. That means a battery cell structure. One is a cylindrical cell, and another one is a prismatic cell, and another one is pouch cell. So first one, this is a cylindrical cell. It consists of a sheet like anodes, separators, separators, and cathodes that are sandwiched and rolled up and packed into a cylindrical shaped can. So this type is one of the first mass-produced types of battery, and also it is still very popular. Yeah, correct. A battery is a pack. Battery pack is a set of any number of identical batteries or individual battery cells. So these cylindrical cells are suited for automated manufacturing. Another advantage of this cylindrical cell structure, that is the mechanical stability. So the round shape of the battery it distributes the internal pressure from side reactions overall the cell circumference almost evenly. So this allows the cell to tolerate a higher level of internal pressure without deformation. And main thing of this cylindrical cell structure is the package is low. The next one is a prismatic cell. So this prismatic cell batteries are used in consumers electronic sites, especially in electric vehicle. So they are shaped similar to a pack of gum or a small chocolate bar. So while they come in a different size, so there is no universal format and each manufacturers design it own. Next one is a pouch cell. So this pouch cell, this is a soft pack batteries make efficient use of space and are popular use of their lightweight and simple and flexible design. This is our battery model design. Today we are going to talk about battery model design by using a MATLAB and Simulink. So first we have to create a cell and after that parallel assembly, then go to the module and module assembly. At last, we are going to design our battery pack. Let's see one by one. So before we enter into that, so join our internship and you will not only benefit from 30 days of live sessions, but also gain access to an extensive ranges of resources, and including 30 days of live sessions and including a 10 plus source codes for a BMS design algorithms and cell balancing methods like that, and also a 30 downloadable presentation, and you have a engaging mentor sessions, mastermind sessions, and also you will receive an official intensive internship certification all in a 90-day package that designed to your career. So use this fantastic opportunity to join our internship program. So you can be an internship user where you will work on exciting projects like creating basic battery model simulation and basic battery pack simulations and designing the thermal influenced battery models and mastering the state of charge estimation methods and state of health estimation algorithm methods and constructing the battery pack with the integrated cell balancing circuitry and also designed advanced lithium equivalent battery cells and also generating the BMS code, and at last we have a conducting closed loop BMS testing in the MATLAB Simulink software. So don't miss this opportunity to gain hands-on experience in the electric vehicle and BMS field. Use this opportunity to join our internship program. You can become an internship user at the discounted fees 999. Using this coupon code BMS MC1, it's not only budget friendly but also gives you access to the valuable knowledge and hands-on experience and real-time practical experience in this batteries technology. Don't miss this amazing offer. Join our internship program today and grab this opportunity in the electric field and electric vehicle and BMS field. So let's get started. Create our battery model object in MATLAB Simulink software. So first we will create our cell object. As I said earlier, first we will create a cell and after that we will create a parallel assembly and next model object, and at last we are going to see the visualized battery in a 3D model. So first defining create a cell object. So in this cell object, so step 1 defining cylindrical geometry, and step 2 creating a cylindrical battery cell, and step 3 is simulating thermal effects. So first, in the first step, we are defining the physical characteristics of our battery cell. I will show you the code. So this is our code. So first, we are defining the physical characteristics of our battery cell using the cylindrical geometry. So this object helps to specify the size and shape of our battery cell, which is designed to be cylindrical. So here we set two important parameters. One is the height of the battery and another one is the radius. So height, this property is said to be 0.07 millimeters. This indicating the height or thickness of the cylindrical cell. Yeah, I am using a MATLAB Simulink. So next, this radius, this property is set to 0.0105 meters or a 10.5 millimeters. So this specifying the radius or width of the cylindrical cell, which we are going to use. So think of it, it's like creating a blueprint of our battery cell. So where we determine how tall the battery and how wide it should be. So next, we are going to create a parallel assembly object. So this is our code. So first, creating the model object of this parallel assembly. So in this code, so this is our code. In this code, you are creating the battery parallel assembly object. This object represents a group of battery cells that are connected in a parallel. So here I am using MATLAB version 2022B. This is our MATLAB home page, and this is our command window. Here we are going to give the command to view the batteries object, battery model object. So first we will select our file. So first we are going to create our cell. And first we will initialize this one. I'm using here 2022B version. So first I will import the Simscape battery builder. So this is our code to import the Simscape battery from the library. So next we are going to create our cell object. So for that we need wait, I will give you the so first we are defining the physical characteristics of our battery using a cylindrical geometry object. So this object helps you specify the size and shape of our battery cell. So which is designed to be cylindrical. So here we have to set two parameters. One is a height and another one is a radius. So this height, it will indicating the height of your cylindrical cell, and this radius it will specifying the radius of your cylindrical cell. It's like creating a blueprint of our battery cell where we determine how tall and how wide it should be, like that. So then we are going to creating a cylindrical battery cell. Now we have defined the physical parameters, physical characteristics of our battery cell. We use this information to create an actual battery cell with a cylindrical shape. So we name this cell as a battery cell. So this step, So now we are going to name this cell as a battery cell. So this step is to manufacturing the physical battery based on the design we have specified. So the battery cell equal to cell geometry equal to cylindrical geometry. So this battery cell is now represents a virtual battery cell with the dimension we defined in step 1. So this is our dimension. So next we are going to simulating our thermal effects in this battery. So to make our virtual battery cell behave more like a real one, we wanted it to simulate how it heats up and when it's used. So just like a real batteries generate heat during the operation. So for this, we need a thermal port here. Now, this is our enable the thermal port of our battery. By setting the thermal port to your battery model, we instruct our virtual battery cell to simulate its thermal behavior during the usage. So this helps us understand how the battery cell's temperature changes under the different conditions. So these example I took from the MATLAB website. So based on your requirements, this height and radius will be changed. So this thermal port helps us understand how the battery cell's temperature changes under different conditions. So first, this code defines the physical characteristics of a cylindrical battery cell and create the virtual representation of that cell and it to simulate the thermal effects during operations. So this making it behave more realistically in simulations. So next we are going to create our parallel assembly object. So in this parallel assembly object, first we have to create the model object. So for that, we need this is our code. So battery parallel assembly cell equal to battery cell. So here I will take the number of parallel cells as 4 and rows will be 4 and also topology will be square. So I will tell you. So this line, so you specify that each individual cell within this parallel assembly will be like the battery cell you designed earlier. So number of parallel cell will be 4. So this property tells the code that there are 4 battery cells connected in a parallel within this assembly. So parallel means they work together to provide the more power. So next, rows will be 4. So this property specify that these 4 battery cells organized in the 4 rows. So imagine them stacked neatly. So next one, topology is square. So this property describes how the cells are arranged geometrically within the assembly. So in this case, they are stacked in a square shape, probably 2 cells in each row to form a square pattern. So next, we want to see the detailed modeling. So for that, we need a battery model object. So creating the battery model object, here you can see the number series assembly will be 30. So here we are building the battery model, which is like a big battery made up of a smaller parts. So this model has a 13 group of batteries that work together. So that means a parallel assembly. So they are connected one after the other. So in a series form. So there is also a some gap which is 0.05 meters between each group. So you want to understand how this model behaves. So you are making the detailed model of it. So for that, we are going to visualize our battery now. So for that we need display battery model dot num models. So here the visible is 52. So this 52. So this code, so this display battery model dot num models is to display the number of Simscape battery blocks that used in your battery model simulation. So dot num models, this is the property of the battery model object. It provides the count of Simscape battery. So this display function is used to display the value of the battery models dot num models in the MATLAB command window. So when you run this code, it will show you your numerical value as a 52 in the MATLAB command window. So this value indicates that there are 52 Simscape battery blocks in your battery model simulation. So these blocks represent the various components and details of your battery model, and also knowing the count can be useful for understanding for your simulation and analyzing purpose. So at last we are going to visualize the battery model. So for that we need this code. So this is our code. So after running this code, one window will pop up. So to visualize the battery model, before you build the system model, to view this, it's a model resolution. Use the battery chart object. So for that, we have to visualize your battery model by using this UI figure. So color equal to W. So W in the sense that is a white color. So the purpose of this provided code is to create a user interface figure and also the tiled layout within that figure for visualizing the battery model, its model resolution. So it will getting error. Am I audible? I will check creations. So class timing will be 6 to 7 every day. So today I'm getting an error. Tomorrow we will see the same topic, how to design battery model by using a Simulink. So thank you all. We will continue our exploration of battery module design with MATLAB demo tomorrow. Don't miss out the tomorrow's session. Thank you, thank you, thank you for your active participation in today's live session. So today we have covered a lot of BMS from scratch, from to the battery model simulations. I want to leave you with a reminder of what we discussed today. So just like when we explored what is BMS and why BMS need in electric vehicle and what are the types of batteries that are used for electric vehicles and creating a basic battery model simulations. Remember that you have the power to build the foundation for the successful career in the electric vehicle and BMS field. The same time, 6 to 7 every day, 6 to 7. Thank you all. Thank you. Haris, in upcoming classes, We will use only Simulink, MATLAB Simulink blocks. So 1 to 2 days, we will see the code to run us and also see the battery models and battery pack, how we design. Thank you, Pradeep. Thank you, Home Kitchen Foods. Thank you. Thank you, Murugesh. Thank you. No, not this programming. In upcoming classes, we will see the passive cell balancing, active cell balancing, and SOC estimation methods. Yeah, we will see the 3D animation of a battery pack and battery model. Thank you so much. Thank you. So don't miss the tomorrow class. Thank you all. Thank you so much.